Today's digital world, cybersecurity is locked in a never-ending struggle. Traditional defenses rely on patching vulnerabilities after they're discovered, leaving defenders always one step behind attackers. This reactive approach is resource-intensive and fundamentally flawed, especially as the attack surface grows exponentially. Attackers exploit the same weakness across millions of systems with minimal effort, while defenders scramble to fix yesterday's problems. The result: an economic imbalance that makes it nearly impossible for defenders to keep up. But what if we could flip the script, automate security innovation itself, and put defenders back in control? Enter Forge X4 Cosmos Omega, a groundbreaking system that reimagines cybersecurity from the ground up. Instead of endlessly patching code, Cosmos Omega acts as an autonomous foundry, generating new, accountable security policies on its own. This is a true paradigm shift. Security becomes a generative, evolutionary science, not just a manual process. Cosmos Omega is designed to invert the economics of cyber conflict, making it more costly for attackers and easier for defenders to stay ahead. Let's explore how this revolutionary approach works and why it matters. Cosmos Omega brings three major breakthroughs to the table. First, it introduces Multi-Physics Evolutionary Defense, MPED, a new science that uses a program's physical side effects, like CPU and memory usage, as a high-fidelity information channel for automated security discovery. Second, it pioneers non-invasive policy synthesis, treating applications as black boxes and evolving external security policies without touching the source code. Third, it sets a new standard for provable governance, recording every decision in a tamper-evident, cryptographically chained ledger. Together, these innovations create a robust, accountable, and adaptive security system. Decades cybersecurity has been reactive, identifying exploits, analyzing vulnerabilities, and deploying patches. This cycle is a rearguard action, always ceding the initiative to attackers. Defenders are trapped in a perpetual race, patching holes in a wall that's constantly crumbling. The economic imbalance is stark. Attackers can exploit a single vulnerability across countless systems, while defenders must secure every entry point. In a world where attacks evolve rapidly, waiting for an attack before learning is a recipe for failure. Cosmos Omega challenges this doctrine by automating security innovation itself. Cosmos Omega proposes a bold new vision. Instead of building better walls, build a system that invents better walls on its own. This approach treats security as an evolving science where defenses are not just engineered but evolved. By autonomously synthesizing novel security policies, Cosmos Omega aims to invert the economics of cyber conflict, making it harder for attackers and easier for defenders to adapt. This generative approach is a game changer, shifting the focus from patching to proactive innovation. The heart of Cosmos Omega is Multi-Physics Evolutionary Defense, or MPED. This new science uses the physical side effects of computation, like CPU, memory, and I/O patterns, as a digital fingerprint. These signals serve as a powerful information channel for evolutionary algorithms, guiding the discovery of robust security policies. The breakthrough is a digital immune system, a behavioral classifier trained on unsupervised clusters of physical telemetry. With 99.3% accuracy, this model provides a near-perfect signal for evolutionary guidance, optimizing not just for correctness, but for a physically grounded definition of normal behavior. Traditional automated program repair (APR) tries to fix vulnerabilities by parsing and modifying source code, but real-world code is messy, full of macros, extensions, and platform-specific quirks. Cosmos Omega takes a different path. It treats the application as a black box, evolving external security policies that monitor and constrain behavior without touching the code. This non-invasive approach is dramatically more robust and immediately applicable, especially when source code modification is infeasible. The result is a symbiotic monitor, not an invasive surgeon. High-stakes security explainability isn't enough. Cosmos Omega introduces provable governance. Every decision, mutation, and selection in the generative process is recorded in a tamper-evident SHA-256 chain ledger. This immutable audit trail allows analysts to independently and mathematically verify the entire process, ensuring transparency and accountability. It's a new standard for trustworthy AI in security, moving beyond vague explanations to cryptographic proof of every step. Cosmos Omega leverages evolutionary algorithms, specifically, a standard elitist genetic algorithm with tournament selection. These algorithms excel at navigating vast search spaces, discovering novel solutions that human analysts might miss. The key insight is that the effectiveness of any algorithm depends on the clarity of the fitness landscape. Thanks to the high-fidelity MPED signal, Cosmos Omega achieves rapid convergence using a robust baseline algorithm, proving that the power lies in the fitness signal itself. Current security paradigm is an economic failure. Attackers enjoy exponential returns for minimal effort, while defenders face massive ongoing costs. Cosmos Omega is designed to invert this cost curve. By automating the discovery and synthesis of new defenses, it imposes exponentially increasing costs on adversaries. The strategic objective is clear: make it harder and more expensive for attackers, while empowering defenders to adapt quickly and efficiently. Inspired by the human immune system, Cosmos Omega implements a practical digital immune system. This system distinguishes between normal and anomalous behavior, autonomously neutralizing threats without altering the host's core code. By using physical telemetry as digital symptoms, Cosmos Omega can identify and respond to digital pathogens in real time. This bio-inspired approach marks a significant leap from theory to practical, effective implementation. Automated Program Repair (APR) has long aimed to automatically find and fix vulnerabilities in source code. However, real-world C code is notoriously difficult to parse and modify due to its complexity and platform-specific quirks. Cosmos Omega's initial attempts to parse cJSON confirmed these limitations, leading to a critical pivot. Instead of modifying code, focus on monitoring and constraining behavior. This shift enabled a more robust and universally applicable approach to security. As AI systems take on more critical roles in security, the demand for explainability and accountability grows. Most current techniques offer only post-hoc interpretations, not mathematical proof. Cosmos Omega addresses this gap by providing a cryptographically verifiable record of every event and decision. This ensures that security-critical artifacts are not just explainable, but provably trustworthy, meeting the highest standards of AI safety and governance. Architecture of Cosmos Omega, known as Operation Omega, is built around 5 core components: the Aegis Sentinel genome, the Council of Titans, the Foundry, the Ledger, and the Digital Immune System Classifier. Unlike traditional systems, Cosmos Omega treats the target application as a black box, observing its behavior and physical side effects. This modular design enables robust, non-invasive security policy synthesis, adaptable to a wide range of applications and environment. Cosmos Omega operates in a continuous evolutionary loop. It starts with a population of randomly generated security policies, evaluates them under both normal and malicious conditions, and collects detailed telemetry data. The Council of Titans analyzes the outcomes, and the Foundry integrates their verdicts into a multi-objective fitness score. The fittest policies are selected for breeding and mutation, creating the next generation. This cycle repeats, constantly evolving more effective defenses. Core innovation of Cosmos Omega is the Aegis Sentinel genome, a human-readable data structure representing a complex, stateful security policy. Unlike patch code files, these genomes are modular and can be extended with sophisticated rules and logical operators. This separation of defense mechanism from application code makes the system non-invasive and robust, capable of adapting to complex, real-world environment. This evaluation in Cosmos Omega is handled by the Council of Titans, a suite of analysis agents. The Execution Titan runs the target application in a sandbox, enforcing policy rules and collecting telemetry. The Janus Titan analyzes behavioral outcomes, classifying runs as successes or failures. The Performance Titan feeds telemetry into the Digital Immune System Classifier, providing nuanced behavioral profile. Together, these titans ensure comprehensive, multidimensional evaluation of every policy. Foundry is the master controller of Cosmos Omega's evolutionary process. It manages the population of Sentinel genomes and orchestrates the evaluate-select-mutate loop. By integrating verdicts from the Council of Titans, the Foundry calculates a multi-objective fitness score using the Omega fitness function. This function balances security, correctness, performance, and elegance, ensuring that evolved policies are both effective and efficient. Guarantee transparency and accountability. Every event in Cosmos Omega's evolutionary process is recorded in the ledger, a cryptographically chained, immutable JSON log. Each event is hashed and linked to the previous one, creating an unbreakable chain of evidence. This allows any final result to be audited and its full provenance traced back to the initial state, establishing true algorithmic accountability. Validate Cosmos Omega. Researchers targeted cJSON, a widely used open-source JSON parser written in C. This choice was deliberate. cJSON is complex enough to challenge traditional tools, making it the perfect test case for a non-invasive behavioral approach. By focusing on a classic buffer overflow vulnerability, the experiment proved that Cosmos Omega could autonomously synthesize effective security policies in a real-world scenario. Experiment used 2 canonical payloads to test Cosmos Omega's defenses. The normal payload was a well-formed JSON object representing legitimate use. The attack payload was a large buffer designed to trigger a buffer overflow. The system had to learn to allow normal operations while decisively blocking attacks, demonstrating both correctness and security in real time. Core achievement of Cosmos Omega is its Digital Immune System Classifier. Built through rigorous data collection and validation, the classifier uses physical telemetry from diverse workloads, CPU, memory, disk I/O to identify behavioral profiles. Using unsupervised clustering and a champion logistic regression model, the system achieved 99.3% accuracy, providing a reliable foundation for evolutionary guidance. Omega Fitness Function is the heart of Cosmos Omega's evolutionary search. It quantitatively balances security, correctness, performance, and elegance. Correctness is rewarded based on the classifier's confidence, security is weighted by the decisiveness of the defense, and performance penalties are applied for resource overhead. Simplicity is encouraged through an elegance penalty. This multi-objective approach ensures that evolved policies are not just secure, but practical and efficient. Initial attempts to use syntax-based automated program repair on cJSON failed due to the complexity of real-world C code. This critical finding led to the great pivot, shifting focus from parsing and modifying code to monitoring and constraining behavior. By treating the application as a black box, Cosmos Omega became more robust, adaptable, and universally applicable. Prove its universality. Cosmos Omega was tested across a diverse matrix of hardware and environments: bare metal Intel, virtualized AMD, and containerized cloud platforms. In every case, the system calibrated new digital immune system classifiers to over 99% accuracy and synthesized high-fit security policies. This cross-platform success demonstrates that physical telemetry is a fundamental, robust property of computation. Experiments results were striking. Cosmos Omega's evolutionary process converged on an optimal solution in the very first generation and remained stable throughout. This rapid convergence, achieved with a conventional genetic algorithm, is definitive evidence that the MPED fitness landscape provides a clear, powerful gradient for discovering effective security policies. Final Evolved Sentinel policy was not a simple threshold, but a complex, multifaceted stateful security policy. The AI synthesized a strategy that monitored a combination of signals, using logical operators like XOR, NOR, and NAND, to create a sophisticated defense. This level of complexity and adaptability would be difficult for a human analyst to design manually, showcasing the power of autonomous generative security. Champion Policy's fitness score of +149,997 was a composite of multiple objectives: correctness, security, performance, and elegance. It allowed normal payloads to run with high confidence, decisively blocked attacks, and did so with no measurable resource overhead. The slight deduction for complexity was outweighed by comprehensive achievement across all evaluation dimensions, as recorded in the cryptographically chained ledger. Every step of the evolutionary run was recorded in the cryptographically chained ledger, culminating in a final block hash that serves as a tamper-evident fingerprint of the entire experiment. This immutable record allows independent verification of every decision, fulfilling the goal of algorithmic accountability and setting a new standard for trustworthy AI in security. Cosmos Omega is not just theoretically sound, it's highly efficient in practice. The entire 10-generation experiment involving 200 parallel program executions and analyses completed in seconds on commodity hardware. This computational tractability makes Cosmos Omega practical for rapid, iterative security research, even without specialized resources. Success of Multi-Physics Evolutionary Defense (MPED) was confirmed through rigorous cross-platform validation. The physical fingerprints of benign and malicious executions formed distinct, linearly separable clusters, enabling rapid convergence. This demonstrates that the power of Cosmos Omega lies in the clarity of the MPED fitness signal, a universal, generalizable scientific principle. Cosmos Omega's shift from code repair to behavioral policy synthesis marked a strategic breakthrough. The system acts as an adaptive immune response, monitoring physical side effects and autonomously discovering sophisticated, non-obvious defenses. This reframing from fixing code to constraining behavior suggests a future where autonomous security systems act as external, symbiotic monitors, not invasive surgeons. By implementing a cryptographically chained ledger, Cosmos Omega moves beyond explainability to provable governance. In high-stakes domains like security, this level of transparency and auditability is essential. Analysts can not only accept the AI's final answer but independently verify every step, ensuring trust and accountability in autonomous security systems. While Cosmos Omega's validation focused on a single canonical target, the goal was to establish the validity of the instrument, not exhaust its applications. Generalization to other languages or complex services remains an open question. The performance of any classifier depends on the telemetry environment, and further research is needed to explore broader applicability and potential limitations. Cosmos Omega is expressly designed for defensive applications. Its non-invasive black box approach constrains behavior without inventing new exploits. Human operators retain control, and the system can be disabled at any time without compromising integrity. Before any public release, independent dual-use reviews and red team evaluations are recommended to ensure responsible deployment. Cosmos Omega represents a foundational step toward a new science of proactive generative security. By autonomously synthesizing novel, effective security policies for complex, real-world applications, it proves that defense can be automated, and even the process of security innovation itself. The system's three revolutionary contributions, MPED, behavioral policy synthesis, and provable governance, set a new standard for the future of cybersecurity. Validation of Cosmos Omega is just the beginning. The next steps include evolving more complex behavioral rules, such as finite state machines for network behavior or advanced system call sequences. The architecture is inherently language and platform agnostic, opening the door to applications in IoT, web security, and beyond. Cosmos Omega provides a practical framework for the autonomous discovery of emergent defense mechanisms. Because Cosmos Omega operates on observable physical side effects, it can be retargeted to new ecosystems with minimal adaptation. This flexibility enables generative security for ARM-based IoT devices, web applications, and even smart contracts. By adapting the instrumentation layer, the system can evolve defenses for a wide range of digital environments. Looking ahead, Cosmos Omega could enable a self-hardening system, simultaneously evolving both defensive sentinel policies and offensive attack payloads. This creates a closed-loop perpetual arms race, where the system continuously discovers its own weaknesses and synthesizes new defenses before external exploitation. By shifting from patching flaws to generating tomorrow's defenses, Cosmos Omega fundamentally changes the economics of cybersecurity. Cosmos Omega is committed to open and verifiable science. A comprehensive replication package is provided, including code, data samples, model artifacts, configuration files, and a complete cryptographically chained audit log. This transparency enables independent verification and fosters further research, ensuring that the scientific community can build upon these foundational results. All experiments were conducted on commodity hardware and standard software stacks, including bare-metal Intel tablets, virtualized AMD laptops, and cloud-based Ubuntu containers. Key software included Python, GCC, scikit-learn, and Pandas. This diverse environment validates Cosmos Omega's cross-platform robustness and practical applicability in real-world settings. The Omega fitness function is explicitly defined, balancing correctness, security, performance, and elegance. Each component is mathematically weighted, ensuring that evolved policies are both effective and efficient. Full parameterization is included in the replication package, supporting transparency and reproducibility for future research. Cosmos Omega builds on decades of foundational work in evolutionary computation, cybernetics, and bioinspired computing. The project also relies on the open-source community, whose robust real-world systems and scientific software made this research possible. This collaborative spirit is essential for advancing the science of autonomous generative security. For those interested in diving deeper, the Cosmos Omega project is thoroughly documented, with extensive references to foundational research in cybersecurity, AI, evolutionary algorithms, and explainable AI. The replication package includes a detailed bibliography, enabling further exploration and study of this emerging field. Cosmos Omega signals the dawn of a new era in cybersecurity, one where defenses are not just engineered but evolved. By automating the discovery and synthesis of novel security policies, Cosmos Omega empowers defenders, inverts the economics of cyber conflict, and sets a new standard for transparency and accountability. The journey has just begun, and the future of autonomous generative security is wide open.